graph polynomial function. Let's say you're given this polynomial function of f of x equals to x to the fifth plus 4x to the fourth minus 3x to the third minus 18x to the second. To graph this given polynomial function, the first thing you need to do is to simplify this polynomial function. So to simplify this given function, you need to factor it out first. So looking at the given, you notice that x squared is the common terms, so you isolate that. So x squared becomes in the front right here times x to the third, which is equivalent to x to the fifth. X squared times x times 4x to the second is equivalent to positive 4x to the fourth. Because x squared times 4x squared, you take the degree 2 plus the degree 2, and you take the 4 times the 1 right here, so it becomes 4x to the fourth. The third term is x squared times negative 3x, and it will become negative 3x to the third, because x squared times x, it will be 2 plus 1, which is x to the third, and negative 3 times 1 will be negative 3. So the final answer will be negative 3x to the third. As for the 18, negative 18x to the second, you take x to the second times negative 18, and when you times it out, it will become negative 18x to the second. So this given polynomial function can be reduced into like this form. And this expression right here can be reduced further by using the synthetic division. To do the synthetic division, you need to know first of the possibilities. So you use p divided by q. This is the p and this is the q. The p will be negative 18. What is divisible by negative 18? One of them is plus 1 and minus 1. The second one is plus 2 minus 2. The third one is plus 3 minus 3. The fourth one will be plus 6 minus 6 until you get to plus 18 minus 18 divided by the q, which is 1. When you take the p divided by q, the answer will be the same thing as the p, because whatever number you divide by 1 will be the same number as the numerator. So this is the possibilities for this expression right here. So to do the synthetic division, I will try the possibilities of 1 first. So I write down this expression, the x to the third. I write 1, and then 4 is the same thing, negative 3 the same as right here, and negative 18 the same as right here. So I try the possibilities for 1. When I do the synthetic division for that, the remainder will be negative 16, which is not factorable for the 1, for the possibility of 1. So I try negative 1, the remainder is negative 14. That means it's not factorable. So the negative 1 possibility is not factorable. So I need to try another possibilities until I get a 0 right here. So let's say I try 2. When I try 2, I bring down the 1. 1 times 2 is 2. 2 plus 4 is 6. 6 times 2 is 12. 12 minus 3 is 9. 9 times 2 is 18. Minus 18 will be 0. The 0 indicates that the 2 is factorable. So to write this into a factor form, you put f of x equals to x minus 2 Every time you have a positive right here, you put x minus 2. If there's a negative 2 right here, you put x plus 2. But since the possibility is 2, so you write x minus 2 times this expression right here. This is 1, so it becomes x to the second power. Why is it x to the second power? Because the expression is x to the third, right here. Right here is x to the third. So when you do a division and it's factorable, it'll be a degree lower. So it'll be x to the second plus x plus 6x. It'll be a degree lower and a degree lower and a degree lower, and then plus 9. Once you have that, you write down all your factor form. So this is the x squared that we solved earlier from the beginning. That's one of the x of 0 possibilities right here. The x squared right here. So x squared times x minus 2 times x squared plus 6x plus 9. As for this one, it can be factored out. It'll be x plus 3 times x plus 3. So you just write raised to the second power because it repeats. So once you have the reduced form for the given original polynomial function, it'll be easier to graph this polynomial function. So to find the leading terms for this polynomial function, you take the 2 plus the first degree for this one plus the second degree for this one. So the total degree for this polynomial function is 5. So it's x to the 5th. Every time you have an odd power polynomial function, the graph will look like this. The first quadrant, the end behavior will tilt up. The third quadrant, the end behavior of the graph will tilt down. The second step is to know whether if it touches the x of 0 or crosses it. So when you have an x to the second power, which is the same thing as an even power, it will touch the x of 0. As for this one, the degree is raised to an odd power, so it will touch the x of 0. It will cross the x of 0. As for this one, which is an even power, it will touch the x of 0. So this is a coordinate system. This is a y-axis, and this is an x-axis. So you plot out the x of 0. The x of 0 for this polynomial function will be 0, 2, and negative 3. So you put negative 3 here. You put a point right there, and the 0 and the 2. And we know that x to the 5th power for a polynomial function, the end behavior for the first quadrant is tilt up. For the third quadrant, it will tilt down. For the negative 3, which is the x of 0 for the x plus 2, is raised to the second power. Every time you have an even power, it touches the x of 0. So it will touch like this way because the end behavior is right here. So it will touch the U shape like this way. It will not be like this way because the end behavior is not on the second quadrant. The end behavior is on the third quadrant. So for the negative 3, which is the x of 0 of x plus 3, right? And it's raised to an even power, so it will touch like this way. The U shape will be like this way, which corresponds to the end behavior like that. As for the x of 0 is raised to an even power. Even power touches the x of 0. So you will write like this. It will touch like this way. It will not touch like that way. Because this line right here, it will go like this to meet up with this x of 0. The x of 0, you don't write the U shape like that. Because the end behavior, there's no graph on the second quadrant for the end behavior. So your U shape has to touch like this, because the end behavior is on the third quadrant, and it has to touch this, the -3, the U shape of the -3 eventually. So your x of 0 has to be like this. It's not going to be like that, because there's no end behavior on the second quadrant. As for the x of 0 of the 2, it crosses the 2, right? Because it's raised to an odd power. So you will need to do like this. You will cross the point like this to match with the end behavior of the first quadrant. You will not do it cross like this, because the x to the 5th theorem says the end behavior only work on the first quadrant and the fourth quadrant. So you're not going to cross like that way, because that's not the x to the 5th theorem. Okay, so you cross like this, which matches the leading, which matches the x to the 5th concept. The x to the 5th means your graph, the end behavior will be tilted up on the first quadrant and the third quadrant. So for this one, the x to the second power, the x to the x of 0 of 2, it will cross like this. And once you have all that, you just need to connect the points. So you go like this, and you go like that, and you go right here, and then you connect with the end behavior right there. So this is the graph for this polynomial function. By applying the factoring, the synthetic division, the possibilities of zeros, and the concept of touches and crosses. It doesn't matter how deep you go right here. It doesn't matter, as long as you know that it's negative for the y-axis, and this is negative for the y-axis. It doesn't matter how negative it goes. But it really matters for the end behavior. Note that x to the odd power, the end behavior of the graph will tilt up for the first quadrant, and it will tilt down for the third quadrant. If you are not sure how to, like if the graph will be like this or like that, or for right here will it be like this, if you're very confused, you could do a plug-in method. So you take this original polynomial function and plug -2.5 and solve for it. So when you solve for it, it'll be negative. So it'll be -7.03. So it'll be right here. It doesn't matter if you go all the way down to -7.03. You just have to know that's negative. So there's one negative point right here. So you just connect this one with that. It's not positive, right? So it's negative right here. And the second point you could do is 1. When you plug in the 1, the answer will be negative. It will be negative 16, right? So it doesn't matter if you put negative 16 or not. You just have to know that it's negative. So you just connect this one with that. It's not positive, it's negative. So you just do that. But using the plug-in method is too long. So it's better to do the concept of touch and crosses, and also the general theorem for the odd function.